Alrighty, so here we go, going through this. Oh yeah, I'm so glad, I would have forgot. I'm so glad you saw that. Okay, we're all good now, thank you. Okay, so we have, is to simplify the expression. Remember, expressions do not have equal signs, they're just simplification. So we have -2 times all that stuff. We would distribute -2 through, that's -2x's. -2 times -3 is +6, right, everybody? All right, and then we have -4x still plus 5. -4x plus 5. From there, it's just simply combining like terms, but being really careful. Some of us struggled a little bit with combining negatives and stuff correctly. So very carefully, guys. -2x's subtract 4 more x's is -6x's, correct? And then we have +6 plus 5, which is 11. And that's in standard form, so this would be the appropriate answer. How many of you got it right? Raise your hand. If you didn't get it right, then do you see where you made your error? Hopefully so. Okay, next one, it says solve the equation. So the difference between the expression and equation is expressions didn't have an equal sign and the equation does. So solving this one was, I made it difficult on purpose. We've got to get some of those difficult ones in. So first of all, there's a lot of things we had to see with this. First of all, we have -x, and then it's minus all that stuff. So technically, you guys, we have a -1 in front. We'll distribute that through by multiplication, so that's -x, right? And -1 times +1 is -1. Is everybody comfortable with how I got this far? Okay. Then we have +5 out here is equal to 8. So over here, we would combine like terms. Now, don't make the mistake of saying your x's go away. -1x minus 1 more x's is -2x's, right? So we have -2x's, and then -1 plus 5 is +4. That's equal to 8. Now it's just solving for x piece by piece. Subtract 4 from both sides. So -2x's is equal to 4, right? Divide by -2, divide by -2. So x is equal to -2, right? How many of you got that one right? You should be jumping for joy. That one was pretty hard, actually. Good job. Awesome. All right, moving on. Let's get going to what we're learning today. So you can take notes on your note sheet or look at that, and then there's also your practice sheet. We're going to go really a little bit slow with this. Pay really close attention because this is actually really hard for students every single year. But hopefully the way I teach it will make it a little bit easier on you. Hopefully. So it just takes some practice. So we're going to be dealing a lot with factoring in secondary math too. Right? Today we're going to focus on factoring out the GCF, which means greatest common factor. So first of all, we need to make sure we're good with vocabulary so that when I say something, you're not like confused at what I'm talking about. We need to know what terms mean. So terms are separated by plus or minus signs. Once again, if I say, what is the greatest common factor of each term, in each term, terms are just separated by plus or minus. So look at 2x plus 4. There's 2 terms here. You see what a term is? There is 1, 2, 3 terms in that. So does everybody understand what a term is now? Okay. Terms are separated by plus or minus signs. So that had 2 terms, 3 terms. So let's just get right to the example. So to factor out greatest common factor, we'll look at each term and factor or pull out the greatest thing in common. And then we will go back and divide out the greatest common factor out of each term to see what's left in each term. So let's look at this 2x plus 4. There's 2 terms here. What is the greatest thing in common in each term, in both terms? 2, right? Don't they both divide by 2? So what we're going to do is we're going to pull out a 2. Now we weren't able to pull out everything, so now we're going to put a parentheses, and we're going to go back and look at each term. So let's focus on this first term. Now this is what I need you to do. I'm going to make you do it because even me, and I have a math degree, I go back and write this. To see what's left in your parentheses, you'll divide each term by what you pulled out. So now it's easier to see what's left. 2x divided by 2. Don't the 2's divide out to be 1? So in the first term, there's an x left. You see how I did that? Positive 4 divided by 2 is positive 2, right? Positive 2? So we write plus 2. And we're done. Does everybody understand factoring the GCF so far? Now look, I could check my answer by multiplying that 2 back in. So we would have 2x plus 4 if we distributed the 2 back in. So we end up back where we were, so we know we've done it correctly. Questions? To the next example here. X squared plus 2x's. What's in common? We have 1, 2 terms. What's in common? There's a 1 in common. Always a 1 in common. You're right. What else? X. X squared. Isn't that just x times x? Okay. And we have an x in this one. So yeah, there's an x in common. So I'm going to pull out an x. Now I've got to go back and write my parentheses and see what's left in each term. So in the first term, now we divide every term by what we pulled out. X squared divided by x. Properties of exponents. When you divide, you subtract, right? So 2 minus 1 is 1. So we have an x to the first left here. Then we have positive 2x divided by x. Don't the x's divide out? So we're left with plus 2. And we're done. Are we all good with greatest common factor so far? For sure? So look, if I distributed that back in, that would be x squared plus 2x's. And that is what we have. Now here's one way we check to make sure we actually factored out the greatest common factor, because there's usually going to be a common factor, but we need to factor out the greatest common factor. If you look back in your parentheses and there's something more you could divide out, then you should have pulled that out too. But x plus 2, nothing more in common. X plus 2, nothing more in common. So that's how we'll kind of check our work. Okay, let's do some harder ones. For problem number 1, here we go. Some examples on your paper. I write it down. That's what you're going to be able to keep, take home, refer back to. So let's look at number 1. We have 2a to the 4th plus 8a. We have 2 terms. Let's focus on the 2 and the 8. Don't both of those divide by 2. So we're going to pull out a 2. Then also we have a to the 4th and an a. So don't we have at least an a here? And we have an a here. So we're also going to pull out an a. So now I'd say to myself, okay, I wasn't able to pull out everything, so I've got some parentheses. And now we'll go back and divide each term by what we've factored out. So let's focus on the first term. 2 over 2 divides out to be 1. Right? A to the 4th divided by a. Now, isn't this a to the 1st? When you divide the same base, you subtract the exponents. 4 minus 1 is 3. So we have an a to the 3rd left in our first term. Then moving on, let's simplify it in sections. What's positive 8 divided by 2? Positive 4. We just simplified those. Then a over a is 1, right? So we're done. Okay, then we could check our work by multiplying back that in. So we have 2a to the 4th. 2a times a cubed is 2a to the 4th. And then 2a times positive 4 is positive 8a's. So we're just checking our work. Isn't that what we started with? Yes. Okay, awesome. This would have been our final answer. Let's do another one. Here we go. Problem number 2. Let's go a little bit quicker. What's the greatest thing in common? You tell me. Go. Tell me. Talk to me. Talk to me. 5. Let's factor out a 5. So then divide each term by 5 and see what's left. 5 over 5 is 1. So x cubed is left, right? Careful here. Negative 10 divided by 5 is negative 2. And we're done. Let's do another one. Number 3. It looks a lot scarier than it is, so don't get scared of it. We have 2 terms. Now, very carefully, 8 and 12. 12 doesn't divide by 8, right? So this is how I go about thinking about it. Let's go to the smaller one. 8 is smaller than 12, correct? So what is the largest factor of 8? Now remember, factor means what multiplies to be 8. 4, right? Doesn't 8 divide by 4? Well, let's look. Does 12 divide by 4? Yes. They both divide by 4, so for the numbers, we're going to pull out a 4. Now let's look at our A's. This one has an A, this one has 2 A's, right? So we'll factor out at least an A, but we can only pull out 1 A, right? This has 2 B's, this has 3 B's. So can't we at least pull out 2 B's out of each of them? So let's pull out a B squared too. So now we'll say, okay, we know that's our greatest common factor, but let's go back and write what's in each term, what's left over in each term. So go back and write this in. I promise you guys, this is going to help you so much. Divide by 4ab squared, divide by 4ab squared. Whatever your greatest common factor is, you'll divide each term. Then you'll simplify it correctly because you're going to simplify it in sections and then you can't mess it up. 8 divided by 4 is 2. A over A is 1. B squared over B squared is 1. Negative 12 divided by 4 is negative 3. Very good. A squared divided by A to the first. Isn't that divide, you subtract, so won't that be A to the first? Right? 2 minus 1 is 1, A to the first. Or we could think of it like this. 2 A's divided by 1A is just an A. B cubed divided by B squared. So when you divide, then you subtract 3 minus 2. Or you could think of it like this. There's 3 B's on top, 2 B's on bottom. So left is B to the first. B is left. And we're done. Now check our work. Look in your parentheses. Was there anything more we could have pulled out? 2 and 3 ABs. No, right? Do you see what I'm saying? So we know we've done it correctly. Okay, next one. Number 4. Do you want me to let you try it real quick? Try it by yourself. Okay, go. We'll go through it and check your work. So we have a 5 in each of those. So 10 and 15 don't divide. This is how I think through it. But 10's greatest factor is 5. Does this divide by 5? Yes. So I pull out a 5. This has 3 C's. This has 1 C. So we can only pull out 1 C. This has 2 D's, 3 D's. So we can at least pull out 2 D's. So then divide each term by 5. C, D squared. Divide by 5. C, D squared. Divide it in sections. 10 over 5 is 2. C squared over C cubed over C is C squared. D squared over D squared is 1. Negative 15 divided by 5 is negative 3's. C's over C's divide out. D cubes divided by D squared is D to the first. Okay, good. A lot of you got it. A lot of you were close. A lot of you got it. Okay, awesome. Just a couple more examples, then I'll let you go. 5f minus 20g squared. Greatest thing in common. So let's look at our numbers. 15 and 20, they don't both divide, right? The greatest factor of 15 is 5, right? Does 20 divide by 5? Yes. So we'll pull out a 5. F, no F's. G's, no G's. So the only thing we can pull out is 5. Divide each by 5. So left would be 3 F's. 15 over 5 is 3. There's an F left. Negative 20 divided by 5 is negative 4's. G squared, still a G squared. Questions on that? Okay, we're almost there. Looking at this one, number 6, 3y to the 4th plus 9y squared minus 15. So looking at this, we have a 3 in common, right? So all of those divide by 3. So we'll pull out 3. Now careful here because a lot of people mess up. They'll say, this has 2 y's, this has 4 y's, so we can pull out a y. But this one doesn't have any y's, right? So we cannot pull out a y unless all of the terms have it. So we'll just divide by 3. Divide by 3, divide by 3, divide by 3. So then we have a y to the 4th left plus 3y squared. 9 over 3 is 3. Y squared. Negative 15 divided by 3 is negative 5. And that's all we can do because there wasn't a y in the final term. We're almost there. Looking at this one, number 7. 10d to the 7th plus 2d to the 5th. 10 and 2, don't they both divide by 2? So plot of 2. This has d to the 7th, d to the 5th. So this one has 5d's, 7d's. 7 D's at least has 5 D's, so we'll pull out D to the 5th. Divide by 2D to the 5th, divide by 2D to the 5th. So simplify in section. 10 over 2 is 5. D to the 7th divided by D to the 5th. Remember, when you divide, you subtract the top from the bottom. 7 minus 5 is 2, right? So we have D squareds left. Now this is where people mess it up. They say, oh, these just divide out and go away. Nope, they don't. They don't magically disappear. They become a 1. Anything divided by itself is 1. We've got to get used to that. Don't say nothing. There's a 1 there, so and it's a positive 1. So plus 1. Questions? Okay. We're almost there. We are almost there. 7W to the 5th minus 35W squared. There's a 7 in each term, so we'll factor out a 7 because 35 does divide by 7. W squared W to the 5th. So we can pull out a W squared. So divided by 7W squared, divide by 7W squared. So in our parentheses, 7's divide out, W to the 5th divided by W squared. Subtract 5 minus 2, which is 3. Negative 35 divided by 7 is negative 5. And then W squared over W squared is 1. Okay, number 9. We're almost there. Then I'll let you just practice the rest of the time. 2x plus 2y. What's in common to 2, right? Pull out a 2. Divide each term by 2. The left is x plus y. Pretty simple, right? Number 10. Okay, here's one thing we do need to know. Okay, so, and I should have said this a little bit more sternly. We have negative 32y squared minus 24y. Only if you have a negative in front. If there's a negative in front, we're always going to factor out a negative with our greatest common factor. It doesn't matter if this was positive in front and this was negative, you would not factor out a negative. You only factor out a negative if the negative's in front. So we'll ignore the negative for a minute. 32 and 24, which one's smaller? 24, right? What's the greatest factor of 24? If you didn't know, you could do 24 divided by 2, divided by 3, divided by 4, 5, 6, 7, 8, right? So 32 divided by 8. Take your calculator. Go 32 divided by 8. What is it? 4. So it does divide by 8. So we're going to factor out 8, but we're not only going to factor out 8. Because there's a negative in front, we're factoring out negative 8. You would need to do this to be considered correct. And then also, this one has a y. This has 2 y's, so we can also factor out a y. So we've got to be really careful when we go back, because we've got to divide by negative 8y. Divide by negative 8y. And we've got to not mess up when writing what's left inside our parentheses. So let's very carefully think about this. Negative 32 divided by negative 8. A negative divided by a negative is positive. We said it was 4, right? So those became positive 4. Then y squared divided by y is y. Now careful here. Negative 24 divided by negative 8. A negative divided by a negative is a positive. So it'll be positive 3. Y's divide out to be 1. So once again, if there's a negative in front, we factor out a negative, no matter what. Okay, here we go. Okay, let's do a little bit one that looks a little bit harder, but it's not. We're almost there. The rest of the time will be yours to practice. I really think you'll be able to get this finished in class. So just stay with me, please. So, first of all, we have 1, 2, and 3 terms. Let's focus in pieces instead of the whole big picture here. 6, 2, and 4. What's the greatest thing in common? 2. We do not need to factor out a negative because there's not a negative in front here. So we're factoring out a 2. X squared, x, and x. The greatest thing we can factor out for x is just 1x. And then y squared y. So we can only factor out 1y, right? There's 1z, 1z, 1z. Oh, looks like we can factor out 1z. So now go back and just write it underneath. It really helps. Even I do it. And so write it in. So then simplify it in sections. 6 over 2 is 3. X squared over X is X. Y over Y, Z over Z. Positive 2 over 2 is positive 1. X over X is 1. Y squared over Y, won't that just be a Y? Positive Y, so it's plus 1. So plus Y, Z over Z is 1. Negative 4 divided by 2 is negative 2, correct? X over X is 1, Y over Y is 1, Z over Z is 1. And we're done. Okay, sweet. Do I need to do another one, or do you feel comfortable? I need to know how you're feeling, because if you're feeling comfortable, I'll let you go for it. Yes or no? Comfortable? Do you want a couple more? You guys tell me. This is the class to help you. So what do you want? More examples, or do you want to practice for a while? You're good? Everybody's good? Feeling good? Okay, if we need to come back, we can. And we will want to come back to some of these. But let's let you practice for a second. So just start in on that worksheet on your practice, and then we will have to come back in just a second for a few more. I'm going to change this example real quick just so we can practice it. I'm going to change this one, so you don't need to write it down on your paper, just look. I'm going to change this to be a negative in front. So we have a lot going on with this, but we just focus on it in pieces. Here's 1 term, 2 terms, 3 terms, 4 terms. Now only because there's a negative in front, do we divide out a negative with our greatest common factor. So let's just focus on the numbers, not the negative for a minute. 12, 4, 8, and 16, no, they all divide by 4. We would want to pull out a 4, but we're going to pull out negative 4. A to the 4th, there's 4 A's here, 3 A's here, 2 A's here, 1 A here. We can at least pull out 1 A, but only 1 A, because that last term only has 1 A. 3 B's, 1 B, no B's, and 1 B's. We cannot pull out a B, okay? 2 C's, 2 C's, 1 C, no C's. So we cannot pull out a C. Does everybody understand that? So we have divide by negative 4A, divide by negative 4A, divide by negative 4A, divide by negative 4A. Negative 12 divided by negative 4 is positive 3. A to the 4th divided by A to the 1st is A to the 3rd. B cubed C squared. Then negative 4 divided by negative 4 is positive 1. I'm not going to write positive 1 right now, just in case there's something more left. A cubed divided by A to the 1st is A squared. We still have a BC squared left. Positive 8 divided by negative 4 is negative 2. A squared divided by 1A is A. And then C, still a C. Negative 16 divided by negative 4 is positive 4. A over A is gone, right? To be 1, actually. And then a B. And we're done. We can check inside our parentheses, nothing more in common. Uh-oh. Uh-oh. There is something. Oh, no, this one didn't have a B. I was going to say I forgot B, but this one didn't have a B. Okay, here we go. Number 13 on your other worksheet. You might want to write this down in case you get home one day or in the future you're struggling with it. So we have 2 terms here. 1, 2 terms. What's in common in each of those terms? Pretty straightforward. It's not a trick question. What's in common? X minus 2, right? Isn't there an X minus 2 in common? So that's what we're going to factor out. We're doing this for a reason. It's going to help you with what we're going to do with quadratics. So we can pull out X minus 2. So now let's see what's left in each term. Go back through just like any other greatest common factor and divide by X minus 2. So then look, in the first term, there's just a 3 left, right? And in this term, there's a positive 4 left. So then yes, this one happened to be X minus 2 times 3 plus 4, which this one happened to be times 7. That would be good enough. Kind of a weird one. All right, I don't really love that example. Next one though. 14, this is a much better example. We have that and that term. What's in common? Isn't it X plus 1? So we'll factor out X plus 1, divide each term by what you factored out. So look, in the first term here, there's an X left. Then divide those out, and we're left with a minus 2 in the second term. That's actually going to be our last step in factoring a quadratic in next unit. Okay, so that's why we're learning this. Okay, number 15. We have this term and this term. Isn't there a 2x plus 1 in common? Do you see it? Divide each term by 2x plus 1. Divide each term by 2x plus 1. Those divide out. In the first term, that leaves me with x cubed. In my second term, it leaves me with plus 2. Are we all good with that? Do you understand how to do these ones? Okay. So I don't need to do this one. Okay. Do the worksheet. Finish it up and hand it in after you've checked all the answers with me.